In this recording, we're going to expand our understanding of solving quadratic equations by factoring. We're going to look at a couple more challenging equations here. So we're going to start out on example 2, actually. We're going to skip down to example 2. So first we're going to start to factor this. And if you remember for our factoring, we said there's a certain kind of factoring we're always going to look for first. See if you remember what that is. Hopefully you said greatest common factor. We're going to look for a GCF first, always. There's not always going to be one, but there is here. The GCF is 3x. There's a 3x that goes into each of these two terms. So we're going to create our little box, and we're basically going to undistribute. It's only a 1 by 2 box because the GCF means there's a monomial times a binomial that creates this quadratic. Okay, so we've got our two terms inside. We need to find out what the 3x multiplied by to become 3x squared. X. What the 3x multiplied by to be 9x. 3. Okay, so now we have our factorization. 3x times the quantity x plus 3 equals 0. Okay. So to solve this by factoring, we're going to set each factor equal to 0. Remember our zero product property? So we've got 3x equals 0. Or maybe x plus 3 equals 0. Go ahead and solve each one of those for x, please. Well, when I divide both sides by 3, just get x equals 0. If I subtract both sides by 3, x is negative 3. So I feel like I have my two roots, my zeros. I write them in set braces because it's a set of x values that make the equation true. And there I have my solution. Let's confirm that solution graphically and by our table. Okay, so over on this margin space, we're going to create an xy table. And we're going to do so by entering this function into the calculator and having it produce a table for us. So we'll go into our y equals. If you have your own calculator, you can play along. We're going to enter the function. We're going to hit second table. Now, what part of the table should we look at? Well, I don't see symmetry here at all. So I'm going to scroll up till I start to see it. Okay, now I'm starting to see some symmetry. Of course, oops, a little too far. Of course, some of these points are way off my screen, right? So that's not helpful. I can't graph 54, so I can't even graph 30. I'm not sure I can graph 12, but I'll try. So I'm going to start with -4, 12, -3, 0, and so on. So let's pop these points into our table. We had -2, 6, -1, 6. Well, that's weird. There's a repeat with no number in between. That must mean there's a lower number than -6. We'll leave a little space for that. So again, leave a little space in there for a lower point even than -6. 0, 0, 1, 12. Ideally, we'd like to have 7 points in the table, which we will have. Now, where's this point coming from? Well, we can kind of get a sense. I mean, you're counting by ones. You got a sense that this probably is between -2 and -1. Let's confirm that. Do you remember our axis of symmetry? Let's work that out down here. Right? Your axis of symmetry was x equals -b over 2a. Okay, think for a second. What are b and a in this example we're thinking about? I should say opposite b. That's how I'm saying it now. Opposite b over 2a. So a is 3, b is 9. So we've got opposite b over 2 times 3, 6. So when I divide -9 by 6, I get -1.5. Not shocking, right? We thought it would be, negative 1.5, right in that in-between spot between negative 2 and negative 1. Now the only question is, well, what's the y that goes with us? I can't tell just by looking at those 6's. So back over here, here's a handy little trick. All I need to do is be on negative 1, and I'm going to hit the plus key here. Okay. And what that does is it changes my table. This delta in Greek means change. So that's saying, what do you want your table to change by? And I want it to go by 0.5. Now everything's going by 0.5s. So I will scroll up a little bit, and now I can see the symmetry. I don't care about all the other points that go by 0.5s. I'm really interested in when it gets to be negative 2, goes to negative 6. When x is negative 1.5, the y is negative, well, I can't see it very well, negative 6.75. All right, so that's the y value of our vertex. Let's put it in our table. Now, before we go any further, I did catch a little mistake here. I did not have my negative signs on the 6's. So hopefully you caught that in the table, and it just didn't make sense the way things were going. So get those to be negative, those 6's. Plot these points, please. We're ready to transfer our table, which, by the way, checks with our solutions, right? Find the x values of 0 and negative 3 in our table and circle them, please. Okay, that's right here. Remember another fancy name for these places, these x-intercepts? Zeros, right? These are the zeros. Cool. So if these are zeros, that means the y value is 0. What they are. All right, and now let's confirm it with our graph. Okay? So make your graph, play the recording when you're ready. So hopefully you paused and did so. Now at this point I'm out of space for 12, so I'm just going to eyeball it about 2 boxes above the 10 mark. Okay, and again, let's identify those two x-intercepts, or zeros, or roots, or solutions. We're all saying the same thing. All right, so let's advance a little bit. Let's have you go ahead and look at example 5. Skipping ahead, this is the one I'd like you to consider, example 5. So in example 5, we have a more challenging quadratic because the a value is not 1, but it still might be factorable. So let's try it out. We've got a times c. That results in negative 6. So I'm going to start making my list for negative 6. And I need numbers that multiply to be negative 6 and add up to be negative 1. There's an implied negative 1 in front of the c, the coefficient of c, right? So let's do negative 6 and 1. No, that doesn't add up to negative 1. Let's try negative 3 and 2. Yep, there it is. Negative 3 times 2, and negative 3 plus 2 adds up. So, again, there's other ways to do this besides the window, but the window is consistent with how we multiplied our binomials. So let's see if we can set this up with our window. We know we put in our 3c squared top left, negative 2 bottom right. We're going to split the negative 1c into a negative 3c and a 2c. Notice how on the diagonals that adds up to negative 1c. That's what we want. Now we just got to figure out, okay, what's the way I'm going to split up my 3c squared into two factors? It's probably going to be a 3c and a 1c, right? But of course the 3c has to go on this row because it can't go in this column because 3 doesn't go into 2. So 3c, 1c. Well, once you've done that, it's easy. 3c times what makes negative 3c? You've got this, right? Negative 1. 1c times what makes 2c? Again, you've got this, 2. And then check it. 2 times negative 1, negative 2, of course. So what are our factors? 3c plus 2. 1c minus 1. All right, that's equal to 0. See if you can take it from there using the zero product property. Play the recording when you're ready. Okay, so hopefully you took time to set each factor equal to 0 and then solve. So this we've got negative 2/3. So that's one of our zeros. I'll work the other one out in a different color. How about a nice black? One equals the other 0. We think we have answers. We just need to confirm this graphically. So let's set up our table. Again, back to the graphing calculator, 3c squared minus 1c minus 2. Of course, I'm not going to use a c. I'm going to use an x. Go into your y equals, clear out. We'll hit second, table. Now, of course, it's going by 0.5s. I can change that right here where it says table set, TBL set. So I hit second, table set. I can start with -3, that's okay, but I'm going to have the delta table be a 1. Now I'm ready to hit table, second, graph. All right, so let's take a subset of this table. I can't graph anything above, well, 10 really, but I'm going to squeeze a 12 in there. So from -2, 12, -1, 2, those are the points I'm going to start plotting. And we have 0, -2, 1, 0, and 2, 8. Let's see if our answers make any sense. 1 is a 0. Cool. That's great. -2/3 did not show up here, but kind of makes sense that it might, right? Somewhere between -1 and 0, the y values go between 2 and -2, so they have to go to 0 at some point. So it kind of makes sense that it might fit in there a point. Please plot these points. Play the recording when you're ready. Okay, so in terms of graphing this, we're going to go a little bit below. So let's now verify our solutions. We had roots at -2/3. Yep. And +1. Yep. Remember, synonyms are x-intercepts, roots, zeros, solutions. We're all saying the same thing. So -2/3, I'm going to kind of squeeze into my table here. -2/3, 0. That's going to be another one of my roots in my table. It all checks out. Thanks for watching.